Hi again. Let's start looking at the homework from section 2.1. I found over the years that a lot of students actually have quite a bit of trouble with graphing. It's not always instinctive, and that part of the brain is generally among the last to develop. So it just may have been that you were studying it at a time before you were really ready to learn it. And so that may be part of the problem. In this particular problem in section 2.1, we're taking a look at a graph. Now, if you click on the graph, it will open up a larger graph, which you can pull out and make a little bit larger. When you're looking at it, this one in this case isn't a whole lot larger, but you can click up here and make it bigger. When we're looking at this one, it wants us to find the ordered pairs. Ordered pairs give the location of where the points are. So let's start with point A, which is right down here. We start at the origin, which is where the two lines cross. The lines are called axis lines. We have the x-axis, which is horizontal, and the y-axis, which is vertical. The point in the center is called the origin, and it has coordinates 0, 0. Now, when we think about moving on the graph, we want to think about moving to the right, to the left, up, and down. Now, right and up are positive directions. Sorry, there goes my dog. Down and left are negative directions. So you can think of, let's see, being right as being positive, sitting at the right hand of someone, being the right hand man, you're on the right side of the law. All those are positive things. Up is also positive. Heaven is up. It's an up day, you're feeling up, things are looking up, all that's positive. On the other hand, well, the left hand is historically the unclean hand because, well, let's just say we haven't always had toilet paper and most people are right-handed. So the left hand was considered not the hand to shake hands with, okay? So that makes it a negative thing in historical purposes. Not really. Obviously, lots of great people are left-handed. But down also has a negative connotation. Hell is down. You're feeling down. You're down in the dumps. Things are looking down. You fell down on the job. Things are going downhill. Down is sort of a negative connotation. So again, right and up are positive, down and left are negative. So when we're looking at A, starting from this point right here in the center, which is the origin, we first move horizontally. So it's always horizontal and then vertical. It's in alphabetical order by the axis. So x-axis horizontal before y-axis vertical. We move 2 jumps to the right. So that's going to give us a 2 for our first coordinate. Then we move 1, 2, 3 down, and that will give us a -3 because we moved down. So A is the spot, 2 to the right, down 3. Down is negative. Now let's look at part B. Go back to the origin. I've got to move left or right first. So left 1, that means that B is going to start with a -1. And then from there, I'm going to go down 1. So left 1, down 1 becomes -1, 1. What about point C? When I'm looking at point C, I just move straight over here, 1 to the right. I don't go up or down. Well, if I'm not going up or down and I move 1 to the right, it's a +1, and then don't move up or down would be 0. Point D, starting at the origin, 1, 2, 3 to the right, 1, 2, down, negative. 3 to the right, down 2, negative number. What about point E, our last point? When we're looking at point E, again, start at the origin, you have to move to the right 1 and then up 1, 2, 3. Right 1 is a +1, up 3 is a +3. That's how you would plot the points. Then you'll come down here and you'll name which one is which. 1, -1, -1, we have as B. The one that is a 1, 3, we have as E. And the one that is 1, 0, we have as C. And then you can come down here and check your answers. And we've got all green checks. Moving on to problem number 2, it asks us to find the x-intercept and the y-intercept of y equal negative 5x plus 5. Enter a point in an ordered pair format, A, comma, B, including the parentheses. Remember that x-intercepts and y-intercepts are where a line crosses or touches that axis. Think of it as an interception in football. You intercept the football, you actually have to touch it and contact it. So this is where it actually touches or contacts the x-axis for the x-intercept and the y-axis for the y-intercept. Now we're going to write down the equation. The first one was problem 1. Remember to number and circle, and then draw the horizontal bar. Problem 2, I'm starting with the equation y equal negative 5x plus 5. Write your equation in case you make an error. Now we want to find the x-intercept. The x-intercept is where y is equal to 0. In other words, the other team got the ball where the ball is 0. So y intercepted the 0, and that means we replace y with 0, and then we solve the equation for x. So we replace y with 0, and now we need to solve for x. To solve for x, we're going to isolate x. The first thing we need to do is to move the plus 5 to the other side. So we'll subtract it from both sides of the equation. This is the balance point. So I've got a minus 5 on both sides, so it's balanced. That gives me negative 5 equals negative 5x. Then I'm going to divide both sides by negative 5. Again, I'm trying to isolate x. I want x by itself and positive. So I divide both sides by negative 5, and I get x over here on the right and positive 1 on the left. Now that is not the answer that WebWork is looking for. Remember, it said to enter the point as an ordered pair. So when I have an x-intercept, my x-intercept should be written as an ordered pair. X is 1, which goes first since it's in alphabetical order. But remember that the opposite team got the ball. Y is 0. Now we want to find the y-intercept. To find the y-intercept, we go back to our equation, y equal negative 5x plus 5. This time we're looking for the y-intercept. And when we're looking for the y-intercept, again, the opposite team got the ball, which means x is 0. So we're going to replace x with 0. This gives me y equal negative 5 times 0 plus 5. I want to isolate y and get it equal to something. Y is already isolated, and I have 0 plus 5. So the last thing I need to do is simply simplify my answer. That means that y equals 5. Again, that is not the answer WebWork is looking for. It wants an ordered pair. So my y-intercept, remember, is an ordered pair in order, x and then y. X got the ball, so it's 0, and y is equal to 5. Go ahead and circle your 2 answers so that I can find them on your exam. This makes it much easier and much faster for me to grade. And a happy professor is a generous professor. An unhappy professor is a crabby one, and they tend to be less generous. So keep that in mind when you're doing your exams. Let's look at problem number 3. Enter the x-intercepts and y-intercepts of 4x plus y equals 6. Enter a point in ordered pair form, including the parentheses. If there is more than one answer, enter a comma separated list of points. If you don't put the comma, it's going to count it wrong. So be careful and make sure you have a comma between. This time we have the equation of 4x plus y equals 6. Looking for the x-intercept, We know that y is equal to 0 because the opposite team gets the ball. That gives us 4x plus 0 equals 6. And that tells us that 4x equals 6. So we are replacing y with 0. And then we simplify. Now we need to solve for x or isolate x. And that gives us x equals 6 divided by 4. We want to reduce that because that's one of my pet peeves. I don't like it when you leave me to do your arithmetic. So do your own arithmetic and reduce it. That gives me 3/2. Again, they're looking for an ordered pair. So this is 3/2, comma 0. What about the y-intercept? Return to the first equation, which was the 4x plus y equals 6. Now we're looking for the y-intercept. So the opposite team gets the ball, which means x is 0. We're going to replace x with 0 and write out the equation. Then we will simplify. This gives us 0 plus y equals 6. We want to isolate and solve for y, and that means that we get y equals 6. Again, write this in ordered pair form. X is 0 because it got the ball, and y is 6. And this is the y-intercept. It is good to label the intercept so that you know you've got the right one in the right box. Looking at number 4 asks us to simply solve the equation for y in terms of x. There are lots of occasions when we want to have it solved for y so that we can use function notation, or for lines so that we can use slope-intercept form. So getting it solved for y is a skill that you will use over and over again throughout all of your math courses. When we look at this one, we want to isolate y. So first we're going to isolate the negative 6y. We isolate the term that has y in it. So we can subtract the 7 from both sides. That gives me 2x minus 7 equal negative 6y. Now we want to isolate y by dividing by negative 6. There are 2 ways of writing this answer. I would accept either one on the exam. I'm not sure what web work would do, but we can try it and let's see. So on this one, the next thing we want to do is divide by 6. I'm going to do it the 2 ways I think are fine. So on one, I have 2x minus 7 equal negative 6y, and I divide each individual term by the negative 6. This gives me 2 divided by negative 6, which is a negative 1/3, times x. Negative 7 divided by a negative 6 is a double negative, which makes it plus 7/6 equal y. This is actually in slope-intercept form, which is the best form for graphing a line. The other method of doing it is to divide and put it on both sides. And that means that you divide each side of the equation by the negative 6. Now, the disadvantage to this is it's not in slope-intercept form, so it's not ideal for graphing. But it may take this in web work. How would you enter it in web work? In web work, you would have to type in y equal, and then parentheses, 2x minus 7, parentheses, slash for division, parentheses, negative 6, close parentheses. Because there's a negative on the 6, you need to enclose it in more parentheses. I'm not sure which one that web work will take, but you can try it out and see which one gives you that lovely green check. Let's move on to number 5. Looking at number 5, it says find the distance between 9, -1 and -8, -7. So when I'm looking at those, what I want to do is I want to go ahead and graph my points. Now I have used Desmos in order to get a graph grid out here. So let me show you what Desmos is. Desmos is something you can Google, and it's an online graphing calculator and calculator utility that you can use. It's free. It's desmos.com. I simply came out here and took a snapshot of this page and then pasted it over here. Let's see what it wants us to do. Find the distance between these 2 points. Enter the distance as a radical or a decimal rounded to 3 decimal places. Now, WebWork is very picky about its decimal places. You have to do exactly what it says to do. If it says 3, it wants 3, not 2, not 4. Most of the time, it likes 5, which is a lot. So I tend to leave my answers in radical form. Now, when I'm looking at this one, it says 9, -1. Start here at the origin and go 9 to the right because it's a positive 9, and then down 1 because it's a -1. So I'm going to put a ball right here, and I'm going to label that ball 9, -1, right? The second point is -8, -7. Starting again at the origin, move -8 to the left, or 8 steps to the left, and then down 7. So 8 would be this line, and down 7 would be right here. So I can label that -8, -7. Now, what do they mean, find the distance between them? What they're looking for is the straight line distance between the two. I'm going to use a note card. You can use a credit card or your ID or something like that, or a note index card works great. And we're going to connect these 2 points. What they're looking for is the distance or the length of that line. When we do it like this, notice that we can actually complete and draw a triangle. If we draw a triangle, this will enable us to use what's called the Pythagorean Theorem. The Pythagorean Theorem is based on right triangles. Right triangles have a right angle or a 90-degree angle in one corner. The Pythagorean Theorem is the following. It says that if you take the 2 short sides and you square them and add them together, you'll get the length of the longest side squared. C is always the hypotenuse across from the 90-degree angle, always this side. The short legs, you could call this A and this B, or you could call that A and this B, but they are the shorter legs. Well, how long is this side? Well, you can count it out or you can think about it. I moved from the origin 8 steps to the left, and then for this point, I moved from the origin 9 steps to the right. 8 to the left and 9 to the right. Well, that must be 17 apart. So one of them is 17. So I can take 17 and square it. What about the second one? One of them is at -1, down 1, and the other one is at -7, down 7. The distance between the two is subtraction, and that would give me a negative or a positive 6. I can do 9 minus -8, which is 17, and -1 minus -7, which is 6, or you can just count it out. And that will give me 6 squared. This does not give me the length of the distance between the 2 points. It gives me the square. So how do I get the distance? Well, that's the distance formula, but really it's just the Pythagorean theorem in disguise. The distance formula simply takes the square root of a squared plus b squared. Now let's take our calculator and figure out what 17 squared plus 6 squared is. 17 squared, I believe, is 289. Yes, it is. So now I have C equal the square root of 289 plus 36, which is equal to 325. Now, how can I break this down? Is it a perfect square? I'm not really sure. So what I'm going to do is break it down into prime factors and look for pairs of factors. For every pair of factors, I can take out one of them. Now it ends in a 5. In fact, it ends in 25. So I'm guessing it's divisible by 5. So let's factor out the 5. That gives me 5 times 65. Then I want to factor 65, which ends in a 5. So it also has a 5. And that gives me 5 times 13. I have a pair of 5. So 1 5 comes out. And that gives me 5 times the square root of 13. For each pair that's under a square root, one factor comes out and gives me a 5 multiplied by the square root of 13. There was only one 13, which is not a pair, so nothing comes out. This should be review from your previous intermediate algebra course or from high school algebra. This gives me 5 square roots of 13. Now, I've never tried hitting the square root. I usually use the caret symbol with the 1/2 power. The 1/2 power is the square root. Let's see what happens when I put in 5. Now, I don't want 5 into the square root, so maybe I'll need a times. Times would be the asterisk, which would be above the 8. 5 times 13, or actually, let's see what happens. Let's just hit the square root symbol and see what we get. That might be under exponents. Yes, there it is. Square root. Aha! So one way of typing in the square root is to type SQRT with round parentheses. And then I can put 13 on the inside. Let's check our answer and see if we get the lovely green check. Yes. And let me show you another way of typing it as well. You can put 5 times, and then you can put in the 13, and then use the caret symbol, and you raise it to the 0.5 power. The 1/2 power represents the square root, and 1/2 is the same as 0.5. Let's check and see how WebWork deals with that. It likes it. So you can use either method, either SQRT with round parentheses around what's under the radical, or you can use the multiplication, which is the asterisk, and then the power symbol, which is the caret, and then followed by the 0.5. Let's take a look now at problem number 6. This is another distance problem. Enter the distance as a radical or a decimal rounded to 3 decimal places. Again, I don't like doing the decimal places, so I usually enter the exact. We've already done one of these problems, so we'll leave this one for you to try at home. Let's take a look now at the next one, which is slightly different. Find the distance between the 2 endpoints for the line segment shown in the graph. Well, the only thing that's missing here are the ordered pairs. So again, you will start at the origin and we'll count to the right, 1, 2, 3, 4, positive 5, down 1, negative 1. Back to the origin, I have to go left first, 1, 2, 3, 4, 5, negative 5 because I went left, up 1, 2, 3, 4, negative 5, 4. Now it's just like the previous 2 problems, finding the distance formula. Let's take a look at something that's slightly different. And this particular problem, it says, find the distance between the point and the origin. This one I do want to do because some students get confused when it says the origin and doesn't give you an ordered pair. But that's really not a problem. We know that the origin is the point 0, 0. So when we're looking at this, we can solve this problem by putting it onto our graph. So there's my number for the problem. And I'm copying the graph again. Let's make it a little bit bigger so we can see things. Okay, so the origin is 1 point, which is the ordered pair 0, 0. Don't go left or right. Don't go up or down. And then the second ordered pair, starting at the origin, I go left 1, 2, 3, 4, up 1, 2, 3. Left 4, up 1, 2, 3. That's right here. Left 4 is -4, up 3 is +3. So now I'm going to use the distance formula. Another way to do the distance formula is to write it as the square root of one of the x values minus the other x value squared, plus one of the y values minus the other y value squared. It's the same thing as the Pythagorean theorem. So if you like, you can take your card and you can connect the 2 points so that you have the distance between the 2 points. And then you can create a right triangle, which forms the other 2 short legs of that triangle. Note that we do have a right angle right there. And note that C is the side that is directly across from that 90-degree angle. Now, what does it mean x1 minus x2? It doesn't matter which order you subtract in, they're squared. So that way, even if it's negative, when you square it, it becomes positive. When you write it out, you get -4 minus 0 squared plus 3 minus 0 squared. The first one gives me a -4 squared, which becomes 16. Maybe I should write out what I get and do it in more steps. This gives me 16 plus 9. Remember that you have to add first in order to find the answer. You've got to group these together because that's what the radical symbol represents, a grouping. So you add 16 plus 9 first to get 25. And then you take the square root, and the square root of 25 is 5, which is our final answer. Would we have gotten the same thing by just counting? Yes, this is 1, 2, 3, 4. This is 3. If I had squared 4 and squared 3, I would still have had my 16 plus 9. Let's now take a look at the next part, which is problem number 9. This says a man drove 12 miles directly east from his home, made a left turn at an intersection, and then traveled 4 miles due north to his place of work. If a road was made directly from his home to his place of work, what would its distance be? Well, I got that there's someone driving on roads and they want a distance, but that's about it. So let's go back to the beginning and interpret the words. A man drove 12 miles directly east from his home. Let's draw a picture of what we have. Here's his house, front door. We'll give him a tree. He drove 12 miles directly east. Directly east would be to the right. He made a left turn at an intersection. Well, he would turn that way. And then traveled 4 miles due north to his place of work. 4 miles, well, that's about right. So we'll make this a skyscraper. All right, so this is 4 miles. If a road was made directly from his home to his place of work, oh, they're just talking about distance again. So now if I connect the 2 doors and I go door to door, what they're asking is for you to find the distance again. So this is the Pythagorean theorem. C is going to be equal to the square root of each short side squared. This is going to give me the square root of 16 plus 144. When I add 16 to 144, I end up with 160. When I get 160, it's not a perfect square, but I can start breaking it down. First, I notice that it ends in a 0, so it's 10 times 16. 16 is a perfect square. It's got a pair of 4s. 10 is not a perfect anything because it's got 1, 2, and 1, 5. For the pair of 4s, 1, 4 comes out, but the 2 and 5 remain behind, which gives me 4 times the square root of 10. If the road was made as described above, how much shorter would the man's one-way trip be every day? How much shorter? Well, that would be the difference between what he's driving now and what it would be if there was a road directly there. This is the road directly there, and what he's driving now is 12 miles plus another 4 miles, so he's driving 16 miles. If we took 16 and we subtracted the 4 square roots of 10, that would tell us how much shorter his drive is. Let's look at problem number 10. Find the coordinates of the midpoint of the line segment that joins the 2 points, -8, -5, and 0, -6. We're going to need to plot our points, so I'm going to put them here. And this is number 10. And we want to plot the point -8, -5. So -8, -5 is left 8, down 5. Plot and label. The next ordered pair is 0, -6. 0, what does that mean? It's first, so it's left, right. So don't go left or right. -6, down 6. That would be to here. Notice the one that has an x-coordinate of 0 is on the y-axis. All the points on the y-axis have an x of 0 because you didn't go left or right, you just went up or down. Likewise, if you were on the x-axis, you would go left and right, but you wouldn't go up or down, so the y-coordinate would be 0. Now we want to find the coordinates of the midpoint of the line segment. So I'm going to take my index card again, and I'm going to connect the 2 points. But what I'm looking for now is the midpoint. The midpoint should be, well, somewhere around there. It's in the middle, right? That's what we're looking for. The midpoint formula is actually quite simple. For the midpoint, you average the 2 points. So take the first x-coordinate, add it to the second x-coordinate, and divide by 2. Do the same thing for the y-coordinates and divide by 2. And then put this into an ordered pair. So my midpoint is going to be -8 plus 0 divided by 2, comma, -5 plus a -6 divided by 2. -8 plus 0 is -8, so I get -8 over 2. -5 plus a -6 is the same as -5 minus 6. They're both negative. So I get -11 over 2. -8 over 2 reduces and gives me -4. Now I can leave this as -11 halves, or I can think of it as -5.5. You can do it either way. I'll take either answer. I have a personal preference, which is for the fraction. But if it's an exact decimal, you can use the decimal instead. If it repeats, then leave it as a fraction. So do I buy that? -4 would be left 4, down 5.5. That's right there. Yeah, I'll buy that. That looks pretty close to the X mark I made. That's the middle of that line segment. So now you want to circle your answer so that I can find it on the test. Problem number 11 is essentially the same. Find the midpoint between 2 points. Add the 2 x coordinates together and divide by 2. Add the 2 y coordinates together and divide by 2. Problem number 12 is also the same, but again, you will have to make sure that you've got the right ordered pairs. What are the coordinates of the origin? Well, if you're at the origin, the starting place, that's what origin means. You don't go left or right, so that's a 0. And you don't go up or down, so that's a 0. So parentheses, 0, 0, close parentheses. What about the next question? If a point is located on the y-axis, what is the x-coordinate? Let's look at our graph to help. If the point is on here, on this line that goes vertically, what's the x? From the origin, how would I get to any of these points on the y-axis? I wouldn't move left or right, but I would move up or down. So the x-coordinate is 0 because there's no left-right motion. So the x-coordinate would be 0. If a point is located on the x-axis, what is the y-coordinate? Again, we're talking about being on the horizontal axis, which means from the origin, I either went to the right or I went to the left, but I didn't move up or down. Since I didn't move up or down, the y-coordinate will be 0. For our last problem, we want to name the quadrant or quadrants in which the following points are located. So I'm going to reproduce the graph down here. And I'm going to make it bigger so we can see where all these points are. That's probably good. This is number 16. When I'm looking at this, the first one is -7, -10. So I'm going to go left 7, down 10, because they're both negative. Now, what's a quadrant? Okay, well, a quadrant means you've divided it into 4. Quad, quarter, quadrangle, they all mean 4. Quad, 4. All right. So quadrants are named with Roman numerals starting in the upper right. So this is quadrant 1, abbreviated Q1. This is quadrant 2, going counterclockwise, which is the positive direction in math. Quadrant 3 is the one that is to the left and down, and quadrant 4 is the one that's to the right and down. So the point we just found was definitely over here in quadrant 3. Let's look at 3, -4. 3, -4, I go right 3, down 4. Since it went to the right and down, it's in quadrant 4. 4, 9. I'm going to go to the right 4 and up 9. And that puts it squarely in quadrant 1, our favorite, because everything's positive. 0, 9. Uh-oh. 0. Don't go left or right. Go up 9. That is on the y-axis. Now, this is a weird rule in math, but if you're on one of the axis lines, you're not actually in a quadrant. The idea is if you could stand on the border between Colorado and Kansas and not be in Colorado or Kansas. That's the idea. So if you're on an axis, you're not in a quadrant. So for that one, we'll say we're on the y-axis. -4, 5. Left 4, up 5. Hope I'm doing all these correctly. And that would put us squarely in quadrant 2, which goes to the left and up. -4, 0. This tells me to go left 4, but not to go up or down. That will put it on the x-axis. 10, 2. That means go right 10, up 2, and that puts it into quadrant 1. -3, -6, left 3, down 6. That puts it here in quadrant 3. Now we can check our answers and hopefully we get all green marks for all of it. That's the end of the homework for section 2.1. Next, I'll be looking at the homework for section 2.2.